Hello, how you doing? Have you seen how easy it is to get the in-memory vector database, ChromaDB, up and running on your laptop? Well, if not, then watch along with me for the next few minutes and I'll quickly get you up to speed. Okay, let's get started. So first, let me quickly get everyone aligned on what a vector database is. Vector databases are purpose-driven data stores designed to manage high-dimensional vector data, crucial for tasks like recommendation systems and image retrieval. ChromaDB is a vector database optimized for similarity search, offering efficient storage and retrieval of vector data, and is built to handle large-scale data sets with high-performance querying. In simple terms, ChromaDB helps find items that are similar to each other, like finding similar songs or products, by comparing their data points represented by vectors. Similarity search involves finding vectors in a data set that are most similar to a given query vector using distance metrics like cosine similarity or Euclidean distance. So to start using ChromaDB on your laptop using Python, you need to install the necessary Python module. First, in your terminal window, run the command pip install ChromaDB. This Python module provides what is required for running ChromaDB on your laptop. Next, let's look at some Python code that will interact with ChromaDB. First, we create a ChromaDB client, which is the starting point for interacting with the ChromaDB vector database. Next, we create a collection named places within ChromaDB. Think of a collection as like a table in a relational database. A collection will store related vectors. Next, we insert some text into the collection, convert it into vector data that ChromaDB can work with. In our example, we insert small text documents. The first text document is Austin is in Texas. It will have an ID equal to 1 and a key value metadata of state and Texas. The second text document is San Jose is in California. It will have an ID equal to 2 and a key value metadata of state equal to California. Now, our collection contains some vector data along with text documents so we can perform our similarity search. Next, we query the vector database collection to find vectors similar to our input vector. Our input vector will be derived from the input text, where is Austin? The parameter end results is set equal to 1, which indicates that the similarity search should return the one most similar vector in the database collection. The include parameter contains documents, distances, and metadata, which tells the query that the result should include these attributes. In this example, we didn't include the embeddings value, so the actual vectors themselves will not be included in the results. So here are the results. You can see the document Austin is in Texas was returned. This is what we would expect when running this example. So you can see how easy it is to get ChromaDB up and running on your laptop. It's designed to be developer-friendly with minimal setup, great for prototyping LLM-driven apps without needing to set up a big cloud infrastructure. As a side note, a common use of ChromaDB with LLMs is in building RAG pipelines. I plan to do a video showing this capability here very soon, so keep an eye out if this sounds interesting to you. Let me know what you think of ChromaDB. Do you think you might install and play with this vector database with any of your projects? Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching.